Rational equations also are a concern because they're not set up so conveniently that we can just look right at it and figure out in our head what the answer or answers may be. The key to a rational equation is to change it from a rational equation into an equation that we're already used to working, a linear or a quadratic. And we can do that if we multiply both sides by the LCD of all the rational expressions that are in the equation. So by doing that, we hope to eliminate the fractions and get something that's simpler to solve. And I have a couple of examples here. This first one, I have two rational expressions inside this equation. This denominator is y, this denominator is 3y. My LCD is going to be 3y. It contains the y and the factor of 3. We talked about finding the LCD of rational expressions when we reviewed some of the operations before. I'm going to multiply both sides of this equation by my LCD of 3y. I'll use the green pen here to emphasize that. 3y times 15 over y is equal to 3y times the whole right side here, so in parentheses, 21 over 3y plus 2. I have to distribute on the right side. Over here on the left side, though, I put the 3y over 1 so you can see how the y's will cancel, and I end up with 45 over 1, which is 45. Over here, I have to distribute, put it over 1. When I multiply 3y over 1 times 21 over 3y, since they're both 3y's here, these are going to cancel out here, and I'm going to just get 21. I didn't cancel it out, physically cancel it out like I did over here, because I still have to multiply the 3y times the plus 2, and I don't want to cancel it out and think that it's gone. 3y times the plus 2, nothing cancels. It's 3y times plus 2, that would be plus 6y. Well, look how simple this equation is. It's a linear equation. I'm going to undo the stuff around the variable y. I'm going to subtract 21 from both sides. Hope I left myself enough space. This is going to be 24 equals 6y. I'm going to divide both sides by 6. And I'm going to get y is equal to 4. Now, I wrote down here, check the solution, or solutions. And there's a reason for that, a little bit more than like a linear or a quadratic, in that it's not just checking to see if you made a mistake, but you can go all through this work properly, get an answer that looks good, and that will solve this equation that we transformed, but might not solve the original, because it might make one or more of the denominators 0. 4 won't do that. If I go back here and plug a 4 in for the variable, neither denominator is going to turn into a 0. But if my answer, let's say, had been y equals 0, and I plug back in, I get 0 in the denominator, and that's no good. In that case, it's called extraneous, but this is a good answer. I'm going to go ahead and circle this. Again, if you want the solution set, just use the braces there to indicate that. Now over here, this one's a little bit more to it. I have 3 rational expressions, and the LCD is not going to be a simple monomial. This doesn't factor anymore. This is x minus 5. This doesn't factor. This is x plus 1. But this trinomial does factor. This factors into, and I'm just going to put it right underneath it here for convenience, an x and an x. Looks like to get a minus 5 on the end, a minus 4 in the middle, I need a minus 5 and a plus 1. Well, nice. You can see that it's a repetition of the same factors here. My LCD is going to be x minus 5 times x plus 1. So I am going to multiply through both sides by that, by x minus 5, x plus 1. And so again, I'll write it out in green here to maybe let it stand out a little bit. Okay, so that's going to be multiplied times the left side, which is 3x over x minus 5 equals. Now I also have to multiply it times this side here, so let me write her down again. This is going to be x minus 5, x plus 1 times over here 2 over x plus 1 plus 2x squared plus 40 all over this denominator, which I'm going to write in factored form, x minus 5x plus 1. So remember, I'm going to have to distribute over here on the right side. On the left side, just the same as that over 1. You can see the x minus 5s are going to cancel out as a factor of 1, and I'm left with x plus 1 times 3x. Over here on the right side, this is going to be fun. I'm going to have to distribute. I'll put it over 1. When I multiply this times 2 over x plus 1, you see how the x plus 1s are going to cancel? Right? I'm not going to actually cross it out, as I mentioned before. So this is going to be just 2 times the x minus 5, because that would cancel out there. Plus sign here, be really careful when that's a minus sign. This is a plus sign here. If it was a minus sign, you'd have to subtract everything that's going to come out over here. But in the plus sign, I'm a little easier with working out with the signs. I won't have to necessarily put down parentheses. I will, though, to stress that. When I multiply these two things together, you see everything cancels out top and bottom. And I'm left with the quantity 2x squared plus 40. Now, I wouldn't put the parentheses there, even though with the plus sign I don't need it, just to emphasize that if this had been a subtraction sign, you'd have to subtract everything to the right, and that's why the parentheses there are reminding. On the left side, I have to get rid of some parentheses by distributing 3x squared plus 3x. On the right side, I have some distributing. That's 2x minus 10, and then plus 2x squared plus 40. Well, that's a quadratic equation. I've just got to get it into standard form here. So on the right side, I will combine like terms and put it in descending order. A minus 10 and a plus 40 is a plus 30. Ooh, lots of stuff here. I have the x squared on both sides. I'm going to, because I have more here than I have here, I'm going to subtract all 3 of these terms, get everything to the left side. So it's going to look a little awkward, but I'm going to subtract the 2x squared, I'm going to subtract the 2x, and I'm going to subtract the 30 from both sides. Here's an advantage, I think, of taking the shortcut and writing it out right underneath it, what you're subtracting, minus 2x minus 30. Because what students will do is they'll write the minus 2x squared, the minus 2x, the minus 30, like I have here, and they see how it cancels out a little bit more quickly. These do cancel, these do cancel, these do cancel. So on the right side I do have 0. On the left side, combining my like terms, I have x squared plus 1x, right here and here, and then the minus 30. And if I'm lucky, I'll get something that will solve easily, and that will factor. I mean, if you're not sure how to factor it, that's something you'd want to go back and practice. You could use a quadratic formula, but factoring is a little more efficient. I can see it factors. This is going to be an x and an x, 2 numbers whose product is negative 30, whose sum is positive 1. That would be a positive 6 and a negative 5, so a plus 6 and a minus 5. So now I have the 0 product property. 2 things that multiply and give me 0 means either the first one is 0, or the second one is 0, or both. So now I have 2 little linear equations. I will subtract 6 from both sides. And I have x equals negative 6, and over here I'll add 5 to both sides. And I have x is equal to positive 5, and it looks like I have 2 good answers. But remember, I had written it down here before about checking your answers. Let's go back. If I take negative 6 and plug it back into my original equation in the denominators, I think I'm safe. Negative 6 minus 5 is not 0, negative 6 plus 1 is not 0, and you can see that this is just these 2 factors, neither one of those is going to be 0. So that one seems like it's a good answer. But if I take x equals 5 and I plug 5 back in, right here and also over here, both of these denominators are going to become 0, and that's impossible. Can't divide by 0. So this is an extraneous solution. You do not count that. It will solve this equation that's transformed, it just won't solve the original. So you toss him out, you keep the one guy that's good, and I'll write it as a solution set that my answer turns out to be x equals negative 6.